So what we have here, this is actually a program called Odyssey that helped us to visualize some atoms and molecules, and we'll use it from time to time throughout the year. This is, I know we're on video, but feel free to stop me if you have a question. What we have right here are actually radon atoms. This is a model, a representation of radon atoms in the gas state. And so if we hit the play button, we can see what radon atoms would actually do if you could make yourself small enough to see them. And so you can see they're basically these little yellow spheres floating around. Now I have a different visualization that I'm going to show you here as well. Actually, let's go back to this. I'm going to play around with it a little bit. Let's hit the play again. We can actually kind of zoom in and turn around and look at them from any angle that we like. Play. I don't think we. Yeah, we can rotate while it's playing. But so that's kind of you are kind of from the perspective of inside of a little box of radon there. So if we do the same thing with bromine, this is bromine gas, you'll notice a very important difference. What is the difference? Anyone? Dan?
Together.
They're together. You see how they're all paired up? They're all married. They're not loners like they were before. And so bromine gas, by the way, bromine doesn't exist in the gas phase at room temperature, so this would have to be really hot. This is over 184 degrees Celsius. That's really hot. And so, but there are other gases that do this as well. Chlorine would do this. That's what chlorine would look like. Bromine, fluorine. And so some gases, some elements will exist as single atoms, like radon, or like helium, or like argon, and others will exist as pairs. Now, there's a word for pairs that we should probably know, and the word for pairs of atoms, as might make sense after I write it, is diatomic. Pairs of atoms are diatomic. They have two atoms. They come in pairs. And so there's a certain set of atoms that always do this. And so there's atoms that whenever you see them, they will always be diatomic. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. And that's maybe kind of intimidating to memorize those particular 7 elements. But you do have to do that. But it's really easy. It's really easy to memorize because all you've got to do is remember one word. HOFBRINCl. 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 It's like you have, you know, emphysema. HOFBRINCl. So, HOFBRINCl. HOFBRINCl. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. They are the diatomic elements, which means that they don't come in single atoms. You wouldn't ever just have an oxygen atom. You would have a pair of oxygen atoms. So if you're writing a chemical formula for oxygen, it would always be O2. But only when they are elements. In other words, when are you not an element? You're not an element if you've been combined with something else. Water, for example. Water's not an element. It's got 2 elements put together, H2O. Does that O have a little subscript 2 there? No, it doesn't. Why? It's not an element. When oxygen is by itself as an element, it would always get a 2. Whenever fluorine is by itself as an element, it would get a 2. However, if sodium and fluorine were together in a compound, you would not get a 2. There would not be a 2 there. And so it's only when they're alone. And by the way, we're not talking about ions here, we're talking about elements. So This is a whole different discussion from what you would see on your ion sheet. You wouldn't ever say, oh, well, oxide. They're asking me oxide on an ion sheet and on an ion quiz, so oh, that's a HOFBRINCl. No, you don't do that, not for ions. Only for elements. Only when they're by themselves, not charged. Okay? So that will be that.